Try. Okay. I want you to think for a second on a simple program like ls. Would you say that it has a lot of config, needs a lot of config to run? It may be surprising, but ls actually uses their colors to know what colors to print, uses terminal capabilities, discovers them to see the size, what colors, if colors can be printed at all. It uses the current directory also. And don't forget about the arguments. The arguments change dramatically what ls is going to do. Listing with details, listing normal directories, listing a different directory that we are currently on. If this is true for a simple program like ls, then think in really big services, like what we build in Facebook or what you are building in your own companies. The amount of configuration that we have there is really staggering. And what happens when the configuration goes wrong? There is nothing else in your systems that can break things as easy as configuration. So when configuration goes down, your site might be completely down. You might appear in the news. And some people might even call the police when Facebook is down. So it's a pretty big deal. Configuration is really important. In fact, it's not only important, it's really critical. As I said, there are no other things that can break things as quickly as a bad config push. Hi, my name is Guillermo Perez. I'm a production engineer at Facebook. And we're going to talk today about how we use Python as a configuration language in Facebook, and the lessons we have learned, and how it helps us build really solid systems. We have three types of, oh, this is really a problem, okay. Sorry for this, I will try to do my best to summarize that. We have three types of configurations. One is service discovery, basically IPs and ports. On the other side, we have a service environment, which is everything that we use. Yeah. Oh, yeah. One second. Still not showing up. OK, I will try my best. Sorry for this. So we have service discovery, IPs, and ports. We have service environment, which is everything that we need to set up on the boxes before the actual service can run. And finally, we have the service parameterization, which is everything that affects how our service behaves. So all the information that our service needs to run properly. And this is the place that we want to really focus on. For service discovery, we have a lot of tools available, a lot of open source tools that work really well. For example, we have Zookeeper, we have etcd, we have Consul. Those solve very well the needs for service discovery. We have also, for service environment setup, we have Chess, Puppet, Ansible, really good tools also. We use one of each list. But for service parameterization, there is nothing out there. So what we see is that we are using those two systems to fill this gap. We use Chef to deploy service configuration, service parameterization. We use etcd, Zookeeper, all those tools to also try to fix this problem. For example, etcd has confd, which is like the templating language to generate configuration files from etcd values. So that's why we created in Facebook Configurator, which is our internal tool, internal framework for doing configuration in Facebook. Why there is nothing really suited for the service parameterization? The complexity of the configs that we need to push is really high. We have from small files to really 1 megabyte of data that we need for our service to run properly. The change risk is really high. Anything that you change in these configs can break things, and it's very hard to know if this is going to break something or not. A single change in a timeout might seem like totally safe, but it might change something in a cascade fashion and produce really bad results. And finally, when we talk about the speed, we talk about both the frequency and how fast we need to push the changes to the service is fast. So if we compare with service discovery and with environment, we see that, yeah, they might be OK with one of these aspects. For example, discovery also is done for really fast and frequent changes, but doesn't satisfy the others. And using tools for environment configuration, it's also complex. It also involves some risk, but it doesn't have the rate of change that we need. So another option that we have, and this is becoming very, very frequent and is very good, is distributing your configuration as part of your code. This is part of the immutable infrastructure trend that is becoming very common with containers, with Docker. It's really good. The only problem is that we are still having problems with the speed, how fast we can deploy our services. When the site is down and you cannot wait to do a release to fix it, you then start suffering these kind of problems and you need to fix them. OK, now we are going to cover how we solve all those three aspects: configuration complexity, how we deal with the unpredictable behavior, how we deal with the speed that we need to achieve, and finally, the availability. Because if we satisfy the first three items, but we cannot do that in a really available way, we are not solving the problem. We are introducing a new one. So humans are really good at detecting patterns. So we clearly see this graph, and we can immediately tell that there's a problem there. But we are really bad when the config is full of other information, is full of noise. We are really bad at this. So we need to find a way to fix this. To make things worse, in Facebook, we have like the median config is 1 kilobyte. P95, this is percentile 95, so 5% of the configs are greater than 50K, then we start having a problem. And to make things worse, we have over 100,000 config files in our system. So we have a problem. Let's make a quick experiment to even show this better. So imagine that we have a chat service that has several rooms. Each room has a name, list of admins, maximum number of users, timeouts, the amount of memory. And I want you to focus on these three simple rules. Okay, we want to set up a default memory of 1 megabyte. But then we have more than 1,000 users in this chat service. The timeouts will be 10 milliseconds, 500 milliseconds if we are over 5,000 users. And Superman will be always the administrator of the channel. Okay? Now I want you to try to spot the problems. Anyone? Anyone can spot a single problem? One? Wow. What? But it should be in addition to. So Superman should be always, but you can have more. Anyone can spot a single problem here? It's really hard. Yeah, you got one. Nice. So yeah, there are actually 3 problems in here. So in one place, we are missing a 0, so we are using one order of magnitude less timeout that we expected to. In another place, we are using one order of magnitude more memory than we need. And yeah, we mistype Superman. So this is really difficult. We cannot deal with this kind of configurations by hand, right? OK, so how we fix this? Go to the rescue, in particular Python to the rescue. Now if I show you this, OK, now we are talking. Now we can see things, right? Now we see the custom logic. I can read this. I can validate this. This is actual code that will be running. I will only need to validate it once, check that the rules are properly written. We can do nice conversions. We don't have to deal with those microsecond conversions on the fly or megabytes to bytes. we can set the defaults in the same fashion. And if you notice at the end, this is the resulting config. The white chat room has max users 1,000, and that makes magic happens. Depending on that number, we do other choices. But the people reviewing this config file only have to focus on the important stuff, not on all the rules that we set up before. OK, so why config as code? This was not enough. Well, it's more semantic, as we have seen. We can enable features like some feature equals true, and that might translate into different changes in different components, increasing timeouts, reducing something. We can avoid repetition. We have list comprehension in Python, which is very cool, and allow us to generate the default config for a cluster list, for example. We can focus on the difference. We can grab the defaults from somewhere and just make one override, and it's very clear that we are doing this change. When you have a huge test, it's really hard to spot the problems. The code can be reused. We can import from other places. And finally, we can express dependencies. So, for example, we can have a ports file with defining the ports for our application and use it in 2 different places. And this code that we are putting in this system is code that doesn't have to be in your service. And we want that, right? You want your service to be focusing only on what you do best, the business logic and everything, and leave all the code that has to do with configuration completely separate. No one would like to have hard-coded Superman in their code base, right? But it's totally fine to do that if you have a configuration service with code. So, OK, why Python? Well, it's simple, repeatable. I think that this is I don't have to cover this in this talk, in this place. But one important thing from here is that it's really widely known and it's easy to learn. Again, when you are in a scenario of having to fix something in production, everything is down. You don't want to have people trying to figure out the syntax of this templating language that nobody remembers because you don't use it every day. So that's really hard. Under stress, a lot of errors can happen, and if you are not helping the developers do the right things, then bad things happen. So for us, the choice of Python was really clear. It's really widely known, not only in Facebook, in the wide industry. So new people coming to Facebook don't have any troubles with this. If we choose some templating language, it will be a mess. What are the problems of Python? Well, it's interpreted, so we can have those pesky typos on code that is not run, whatever. And we have no strong typing, which might sound like surprising, because for a system that is meant to produce configuration, it sounds like something that we want to have, right? But we can solve those problems. We can have linter rules to detect problems. And also, we are doing compile configs. I will explain that in detail later. And to solve the strong typing, we use schemas and validation. We use Thrift, which is our protocol buffers replacement, to define how it's going to be our data, how it's going to look, the structure. OK, let's see the compilation process. We have the code that we talked about already. We have the schema, 3 files. They just define the types, basically. But the types are not enough, right? For example, we have a timeout. Timeouts, we know that has to be greater than 0, right? It cannot be less than 0. So we need more validation here. That's why we have the validator code. So we can attach a specific function to one data type, to one class. For example, in this case, to chat config, which is a class generated from the Thrift. We attach the function validate config, and it will do some custom checks, basically. Really simple, really straightforward. We're not trying to do rocket science here. We're trying to help people avoid repetition, avoid mistakes. OK, all this is read by the compiler, and the compiler produces a JSON file. This JSON file is static. So it doesn't matter if we have bugs in your code, whatever, as long as we haven't executed that part, and the JSON that we are producing is good, and you verify it, it's totally fine. We grab all this together, and we keep it in a Git repository, so everything is under version control. And if you notice, the JSON is also part of this. What that means? That when we are deploying the configuration to the actual services, we are only extracting the JSON from it. And if we need to revert to a previous revision, we don't need to execute Python again. We just go to the Git repository, ask for give me the JSONs from the previous revision, and we extract them, and we push them again in case we need to fix something. OK, other supported methods that we have. We already commented how we deal with the code and the Git repository. We also provide a programmatic API. We call it the Mutator API for other programs to push config to the system. And we have a specific web UI for editing one config without having to do the full checkout of the repository. And for some specific use cases, for example, we have a lot of A/B testing. This requires a specific UI. Okay, so they developed specific UIs that will push configs and will make creating those specific config files much simpler by having a good UI. So this works, really. Engineers prefer doing config as code. We found that 75% of the configs in our repo are generated via this compiler that I explained before. 22% are done via the API. This means that probably there are other programs talking to this API behind Cortines. And only 3% are manually edited. Those are those ini files for Java debugging, Java GC, those kind of things that cannot be JSON. And some people are still editing them by hand, but really small percentage. And the growth and adoption of this system has been staggering. So this is the backend services repository, code repository, the web code repository, and configurator is growing much faster than any of the two. In fact, it's bigger now than the two of those combined. OK, we covered how we deal with the config complexity, how we have solved the problem of the unpredictable behavior that we have seen. Well, validation is not enough. We are allowing all the engineers to push configs mostly on the first week of they arrive to the company. They are already capable of shipping code and doing changes to any config file. We trust a lot our engineers. So we have developed a system, more or less like, it's not a system only, it's just we trust developers, so they have to follow this process. We start with compilation and validation, then you start doing manual tests. You have tools for doing carrying, for running linters, so you can inspect that the config that you are generating is working properly in your service. When you are confident with your config, you submit it for code review. Remember that this is actual code, so we follow the same rules as for normal code. We'll have linters, we have sanity checks, we have peer review. And finally, once you are good with your config, before pushing, we have an extra step, which is the automatic canary. Even if you are supposed to already have canary in your config and tested it, we will try to do our best to send the config to production environment in maybe some thousand of boxes, and measure if we are breaking anything, and reject the commit if we detect something wrong. So our automatic canary is highly configurable. We can schedule different phases. We can go up to one data center, full data center, for testing for those kind of performance regressions that are hard to test in a small scale. And it takes around 15 minutes to deploy and measure the effect. So it only introduces 15 minutes delay in the user's workflow. Of course, you can skip this if you're really an emergency. And this is only the safety net. As I said before, we trust our developers. You should test your things. We are trying to do the best to avoid mistakes, but we cannot be perfect. There will be some things that are really hard to get, so we are only the safety net here. OK, so what happens if the error got through? Really, we couldn't detect it in time. So we can correlate by time. We have a repository, so we can do git log, git blame. We can try to find which was the offending config. And in case something really goes wrong, we can always do a git revert. OK, so how good we were at this? Previous studies said those numbers. At Facebook, we are in 16%, which is a very nice number. We are on the lower bracket. So from all the problems and incidents that our site had, I think this is over a year or half a year, only 16% were caused by bad config changes, which is, as I said, surprising given that the freedom that we allow to our engineers to push configs and do changes. OK, so now about the scalability. We have two concerns mainly. One is the authoring flow, so how we allow for those frequent changes, especially given that we are having a single Git repository, which might be a bottleneck, as everybody knows. It's a central place, so those things, when you have a central repository, it's always hard. And then how we deal with the distribution flow, how we deal with pushing the configs to hundreds of thousands of boxes that we have at Facebook, and doing so with low latency. So authoring flow. We already talked about the Mutator API, the Canary service. All those will send diff changes, like patches. And we have a landing service that queues all the patches and tries to apply them serially. So this is actually like a patch manager, like a MalQ thing. And it will check if there is any concurrent changes to reject those. It won't try to do merges. It won't try to do anything really smart. Then applies the patches, checks that they apply cleanly, and checks the hooks. It might reject them if something fails. And finally, we push the configs. This makes the Git repository scale to like thousands of commits per day. Imagine doing this on a normal Git repository, trying to rebase. Someone will push the changes before you, and then you have to rebase again. Those kind of fights, we don't have them, thanks to this queuing. OK, and when this is not enough, so we are also creating multiple shards for different projects so they can have their own full setup, and they can scale independently. OK, so how we deal with the distribution flow? Once the configs are landed into the Git repository, we have a tailer that is constantly pulling from this repository and getting the latest changes. And then it pushes them to Zookeeper Global Ensemble. The Zookeeper Global Ensemble is replicated to per cluster of servers. Those are regional. So on every cluster, which is like our unit when designing data centers, it's basically like a hall in a data center. We have a set of observers. And those observers will be the ones that send the config to actual boxes, production boxes, on the same hall. Let's see in detail how the interaction between the observers and the proxies work. So each box has a proxy with a cache, and the applications request configs to the proxy and subscribes. And then they fetch the configuration directly from the cache. They don't go through the proxy. We'll see why later. And the proxy sends the subscriptions to the observers, and the observer, when something changes, it will push them back. So we get really low latency by doing that. We are talking about hundreds of thousands of boxes, and we can achieve less than 30 seconds after the commit has landed to the Git repository with several nines. I don't know how many. OK, now how we deal with the high availability. As I said, it doesn't matter if we are doing all those really right if we cannot really ensure that our system will be up and running. Well, obviously, we have redundant services, or everything we talk about, mutators, canaries, and landing services. All of those are redundant, but they could go wrong, so we have to do trade-offs at some point. For example, if the mutator, canary service, the landing service all are down for some reason, we can still do Git pushes to the Git repository. If the Git repository is completely broken, the tail is not running, we can still do direct writes to the Zookeeper ensemble. Zookeeper is highly redundant, is geographically distributed, so even if a region goes down, it should be still capable of accepting writes and reads normally. But even if the Zookeeper is completely down, or servers are down, everything is down, even the proxy in the box is completely down, our applications are still capable of reading directly from the cache the configuration that we're already running with. And yes, they will get stale. They won't receive any new updates from them until we restore the services. But at least Facebook can be still running properly, even with critical services like configuration completely down. OK, lessons learned. Well, machine-generated configs are becoming more common than we anticipated. This means that they have really high frequency updates, and version control is not as important. Validation is less important because they generated by another program. Even we have some cases of multi-gigabyte configuration files that we deal them separately, separating them from Git. We only store in Git the hash, and we fetch them from outside. Scalability, as we already mentioned them. In addition to Git problems, we also have the demand control, giving this powerful tool that achieves really high throughput and really low latency to distribute to the fleet, and being highly, highly available is really sweet for developers, so they tend to use it a lot. The config as code can be really become messy. We are trying to force our developers to do code that is always idempotent, so no matter when you run it, it will reproduce the same result, but they don't always follow the same rules, so they might start querying like discovery mechanisms. They might put IP addresses in there, so there are bad practices that we need to hunt and fix. Multiple versions, slow rollout and Canary weren't there at the beginning. We are working on them. In smaller systems, it will make more sense to do them from scratch. So when you start thinking about your system, for places like Facebook, it's usually better to start simple and then modify on the road, because what you think that they might need, it might not be what they finally need. So we don't regret doing it that way. And Python was a really good choice for many, many of the services that we talk about. So for example, the Mutator API, the landing service, the Canary service, all of those are written in Python, and was really a good experience. OK, conclusions. Use Python as a tool for configuration. It's really solid. It's very familiar for people. This is very important, as we mentioned. Nobody will have problems to understand and to do changes. You will need to add some kind of structure and validation. For example, you can use type hinting for doing validation and ensuring that your code is solid. Keep your code and validation all in version control, and follow the same procedures that you use for normal code. So do peer review, you do peer review. Don't forget to materialize the configs. This is very important. No matter how you trust the code might be buggy, might not produce the same results always. So it's always important to be able to go back in time to a previous revision when you have to do a revert. And you don't have time to fix some bugs in the code when that's happening. You need to revert to version B, and you then need to do it fast. OK, provide some tools for testing and Canary. If you do this easy for developers will love it, and developers will use them a lot. If you make testing the config changes hard, nobody will use them. They will try to squeeze and skip all your protections. And finally, distribute based on availability at the cost of paying up to date. That means that you don't have to use Zookeeper if you don't have this scale, but maybe are syncing the files generated by Python to the boxes themselves is available enough, because they will be on disk. And even if your system is not pushing new configs, you can still read them from disk. So the final conclusion of this talk is that configuration is as important as code. It's really critical. So I want to encourage us to invest in making tools for it. Don't try to just use what is in the market. So in your tools, when you're building something new, think carefully, think from the beginning, try to plan in advance what you need, and yeah, use Python. Thank you.
Hello. Thanks everyone for coming. Let's give another round of applause to Guillermo, our speaker.